Okay, let's kick things off. AI, it's weaving itself into more and more corners of our lives, isn't it?
Definitely. Think about it. Streaming recommendations, medical diagnostics, even self-driving tech, those chatbots everyone's talking to.
Right. And as it gets, more powerful, more embedded in critical stuff, this huge question pops up. How much can we really trust it?
That's precisely the problem. I
Hmm.
mean, AI can crunch data and spot patterns way beyond what we can, which is amazing.
Yeah, incredible potential.
But then you hear about these AI hallucinations, right? Where the AI just confidently spits out stuff that's, well, wrong or totally unreliable or just plain made up.
Hmm. Especially if you ask it something outside its training zone.
Exactly. That's the danger zone.
It's like that super smart expert who sounds totally sure, but you don't know if it's based on solid facts or just, a really convincing guess.
And when that guess is about a medical treatment or
Yeah.
controlling a vehicle,
Yeah, a confident mistake there could be,
yeah,
well, catastrophic.
the risk, the potential cost, it's very real. So closing that gap, the gap between what AI can do and how reliable it is, that's just essential.
And that brings us nicely to our deep dive today. We've got some really interesting source material here, looking at a solution from MIT researchers.
Right, now commercialized by a company, Themis AI, and their platform called CAPSA.
And it's aimed squarely at tackling this trustworthiness problem we've been talking about.
So our mission for this deep dive, let's unpack this CAPSA tech.
Yeah.
What is it? How does it actually work? Where did it come from?
And crucially, what impact could it have across different fields? Why is something like this potentially non-negotiable for AI's future?
Let's get into it.
All right, so Themis AI, CAPSA platform.
Yeah.
What are we actually talking about here? What does it do?
Okay, so Themis AI spun out of MIT, founded back in 2021. And their main thing, CAPSA, it's not about building entirely new AI models. Think of it differently.
How so?
It's designed more like an intelligent layer that wraps around the machine learning models you already have.
An intelligent layer. Okay, how does that help build trust?
It boils down to quantifying uncertainty and communicating it. The platform gives you real-time uncertainty scores for pretty much any model it's wrapped around.
So it's not like a firewall stopping errors.
Not exactly. It's more like a sophisticated diagnostic tool. It tells you, right now, for this specific question, how confident the AI actually is in its answer.
Okay.
Daniela Roos, one of the co-founders from MIT, she describes it as integrating with any model to sort of pinpoint its uncertainties, its potential failure points. It strengthens the whole system by adding this layer of self-awareness, if you will.
That's a really key distinction. It's not fixing the output itself. It's making the AI aware and telling us about its own potential wobbles.
Precisely.
So how does it do that? How does it know when the AI is maybe flying blind a bit?
Yeah, this is the clever part. It watches the AI model's internal workings, how it processes data.
Okay.
And it looks for specific statistical signals, little indicators within that flow that suggest, things are a bit ambiguous, or the information is incomplete, or maybe it's relying on data that isn't quite representative.
Digital tells, like poker tells, but for AI processing.
Kind of. It spots the signs that suggest the AI isn't on totally solid ground for this particular task.
So the AI spits out an answer, but this capsule layer, having watched the how, can chime in and say, okay, here's the answer, but just so you know, based on the data in the process, we've got a pretty high uncertainty score on this one.
You've got it. It gives the AI a voice to express its own confidence level or lack thereof, and the
Yeah.
sources make it clear this isn't just a lab theory, it's actually being used out there.
Really? Can you give us some examples of what kinds of industries are using this uncertainty quantification?
Yeah, the material mentions several. Telecom, for one. Using AI for network planning where, predicting problems is pretty critical.
Makes sense.
Energy sector, too. Helping oil and gas companies get more reliable reads from complex seismic data.
Ah, interpreting those underground maps.
Exactly. Big applications in healthcare boosting pharma research, helping streamline drug discovery, and yes, in the tech world generally, making those large language models, the chatbots, more reliable.
Healthcare and drug discovery.
Yeah.
That feels huge. If you can make the AI predictions about potential drugs more trustworthy.
Think of the time and resources saved. It's massive. Yeah. The societal benefit could be enormous. Alexander Amini, another co-founder, talks about this drive to enable safe, reliable AI, especially where it matters most, in those critical applications.
Preventing errors there is just paramount, isn't it?
Absolutely. The goal Themis has is to let any AI system predict its own potential failures proactively. before they happen.
Which sounds incredibly valuable. And it makes even more sense when you hear about where this tech came from, its roots at MIT.
Yeah, the sources trace it back to foundational research, started around 2018 or so. Daniela Rus got funding from Toyota, initially focused on machine learning reliability specifically for autonomous driving.
Self-driving cars? Okay, that immediately screams, need to know the AI's limits.
Right. In a car driving itself, knowing when the AI is unsure about what it's seeing or what to do next, that's fundamental safety.
That would be more critical.
Exactly. That field demands this deep understanding of model limitations. And the research also led to algorithms for spotting bias.
Bias, how so?
Like recognizing racial or gender bias in facial recognition systems, and then figuring out how to fix the training data, detecting when it's skewed, and generating balanced synthetic data to correct it.
So the origins were in spotting AI failures, both uncertainty in complex situations like driving, and also those built-in biases from the data itself.
Yes. And there was this key moment highlighted in the sources around 2021. They realized that similar techniques used for car reliability and bias detection could work somewhere totally different.
Where?
Helping pharmaceutical companies predict drug candidate properties using their AI models.
Ah, and that was the light bulb moment for commercial potential, seeing it work in drug discovery.
That's what it sounds like. Daniela Rus mentioned that seeing the potential to save huge resources in drug discovery really made them realize this uncertainty tech could be transformative, way beyond just cars or bias detection.
Okay, let's switch gears slightly. Large language models, LLMs. The tech behind ChatGPT, company chatbots. Many of us interact with these daily now. How does Themis AI help them?
Stuart Jameson, who heads up technology at Themis AI, explains that CAPTCHA lets these LLMs basically assess and communicate their own confidence for each bit of text they generate.
Which seems vital, right? Especially as companies train these models on their own private data.
Exactly. If you're feeding it sensitive internal company info, you absolutely need to know if the answer it gives back is grounded in that data, or if it's just, well, confidently hallucinating based on something else.
You need accuracy, not just good grammar.
Right. CAPTCHA gives the LM a way to flag its confidence. High confidence, low confidence. It helps make the whole question answering process more trustworthy. Crucially, it lets the system say, hey, warning, this response might be unreliable.
Turning that hidden hallucination risk into an explicit heads up.
Pretty much. It addresses the problem head on.
Super valuable. You mentioned edge devices earlier, too. What's the angle there?
Yeah, they're working with semiconductor companies, optimizing AI for edge computing.
Edge computing.
Yeah.
So AI running directly on your phone or maybe a sensor in a factory, that kind of thing, not going back to a big cloud server all the time.
Precisely. And often the AI models you need for those devices have to be smaller, maybe less accurate than the giant ones in the cloud.
Trade-offs.
Right. Jameson points out their approach tries to get the best of both worlds. Fast, efficient processing on the edge, but without sacrificing quality, because the uncertainty score is there.
How does the score help?
Well, the system can be smart. If the edge device runs a calculation and CAPTCHA flags it as highly uncertain, it can automatically send just that specific query up to a more powerful central server for a double check.
Ah, intelligent routing. So the edge handles what it's sure about and escalates when it's not.
Exactly. It makes the whole workload distribution smarter. Edge AI becomes more reliable because it flags its own potential errors, and potentially more efficient because it doesn't waste cycles on things it knows it can't handle well locally.
That makes a lot of sense, using the confidence score to manage resources.
Yeah. And just looping back to the pharma side for a second, the sources emphasize how tricky it is, even for human experts, to interpret the outputs of these complex drug discovery AIs.
I can imagine.
CAPTCHA gives them that immediate insight. Is this prediction solid, based on the evidence? Or is it maybe, bordering on unfounded speculation, as the source puts it?
That's a huge deal. Instead of experts digging through every single prediction to validate it.
Which could take hours, days.
CAPTCHA can quickly point them towards the most reliable ones, potentially speeding up that whole discovery pipeline dramatically.
Which, again, circles back to that societal benefit, saving time, saving money. The Themis team really believes their tech is positioned to enhance AI as it keeps evolving so rapidly.
They're looking beyond current applications.
Yeah, they're even exploring how it might improve things like chain of thought reasoning in
You'd
LLMs.
have thought that's the step-by-step process the AI uses internally to
Yeah.
solve problems, right?
hmm And Jameson mentioned early signs that CAPSA might be able to actually guide that reasoning process itself
How?
by maybe steering the LLM towards the reasoning paths that seem the most confident or best supported by the data, step by step.
Wow, okay.
The idea is this could potentially boost the final answer's accuracy and maybe even make it faster and less computationally intensive by helping the AI avoid going down uncertain rabbit holes.
Like an internal compass, pointing the AI towards the most reliable way to think through the problem.
Fascinating.
For the MIT researchers involved, like Daniela Ruse, spinning out Themis AI was really about making sure that foundational academic work actually translates into real-world impact, tangible impact.
Get it out of the lab.
Exactly. Taking the steps needed to ensure their research on AI trust can actually help tackle these challenges globally, which feels so incredibly timely, doesn't it? AI has this undeniable power, this transformative potential.
But it also brings legitimate worries, as she points out. Safety, fairness, reliability. We hear about these all the time.
So developing technical fixes like this one, systems that help bake trust into the technology, seems absolutely crucial for how we as a society build our relationship with AI going forward.
It really shifts the dynamic, doesn't it? We move from AI just giving an answer, maybe right, maybe wrong,
To an AI that gives an answer and tells you how sure it is about that answer.
a fundamental change.
Okay, so let's just quickly recap the main takeaways from this deep dive.
Right. The core challenge Themis AI and CAPSA are tackling, making AI trustworthy, especially in high-stakes situations, by dealing directly with uncertainty and those AI hallucinations.
And their solution isn't a new AI model, but an enhancement layer. It wraps around existing models, watches their internal processes.
And gives a real-time score for uncertainty. It flags potential failures before they lead to bad outputs.
We saw this tech grew out of years of deep MIT research, starting with things like self-driving car reliability and spotting data bias.
And then hitting a key point when it proved useful for predicting drug properties in pharma research.
And the applications are broad. Telecom, energy, making chatbots more reliable, enabling smarter AI on edge devices.
All with that potential for real societal good, saving resources, improving critical processes.
And this connects directly to you listening, because AI is becoming part of everyday life faster than ever. Trusting these systems isn't just a tech issue anymore,
No, it's becoming fundamental to how we interact with technology safely and effectively.
which leaves us with a final thought for you to chew on after this deep dive.
Yeah.
If AI systems get to the point where they truly know their own limits and can tell us clearly, hey, I'm not sure about this one, how does that change everything?
Yeah, how does that fundamentally alter how we interact with them? What decisions do we suddenly feel more comfortable letting AI handle, or at least influence, if we know its confidence level?
And on the flip side, what new kinds of human oversight or interaction become necessary, or even possible, when we get this unprecedented window into the AI's own state of certainty? What does that enable, and what new questions does it raise?